Good morning, class. I'm audible.
Yes, sir. Good morning.
Okay. So in our previous class, as we have seen that we are talking about lecture 0, and we have talked about various techniques that evolved as with respect to time, right? And then the latest trend that come in picture, right? Then we talked about the schemes, the books, right? All that thing, the syllabus part. This is your syllabus. As you can
Good
see.
morning, sir.
Good morning. Yes. So you can see over here. This is the syllabus of our course, that is computer networks, in which we have these 5 modules: 1, 2, 3, 4, and 5. Right. This is the last one, that is the application layer, module 5. And the layers which we are talking about yesterday, those layers are discussed in each module of this course, right? Data link layer, right? Network layer, transport layer, and application layer. You can see over here, right? So all those layers will be discussed one by one in the chapters as per the syllabus, and we will see that how these layers are basically uh, giving support to the upper layer and the lower layer one by one, right? So I'm just moving to the. Then we talked about that why we need to study this particular course and why it is a professional core subject, because the concepts of networking is extended for all the latest trend that is now in a market. Like you can see it is in a mobile computing, you can see in a cloud computing, you can see even it in software defined networking. Now the current trend which we can see now is blockchain, where you can also see that it is also using the concepts of networking, right? So what we understood in the previous lecture, that the objective of network is to establish a connection, right? As many connection, so that we can able to provide services, we can able to transfer data from one place to another place. Otherwise, that is a problem in our ancient period. You can see that it is very difficult to transmit a data from one location to another location, and again there is a risk behind all that things, such as there could be chances of tampering of data, and that could be very easily, right? Because we are relying on one single runner which will carry your data from one kingdom to another kingdom and all. So all those things are there, but these things, that techniques basically consume more time, right? And even not reliable, and we are not getting the things that it whether that thing is reached to the place with integrity or not, right? So what is networking? We understood that it is basically talking about transferring of data, or we also call it data network, right? Which allow us to exchange our information or data in using these computer devices. That's why it's computer network. And one more thing that we understood is that we cannot transmit our data in a single go, right? What we need to adopt is we have to break them down in some form of packets. That's why that nomenclature came here, that we need to break down, since the channel does not have that capacity to carry the dead data, right? To carry the entire data in a single go, right? So there are some complexities that need to be taken care, and one by one we will learn each and every aspects of this networking, where we're going to discuss. In this particular diagram, you can see how nodes are connected with each other through wired medium, using different internetworking devices. You can see over here somewhere it is written switch, somewhere it is written bridge, there is a firewall, there is a router. So all these things are the part of a network, right? In a domain, right? So when we are connecting a large lab, or we are creating a laboratory, right, there, according to the traffic, we will provide the support of such devices, right? And all these devices, they have their own significance. As you can see, if you want to extend the number of ports, as you have seen in the lab also, where we need to connect with more number of computers, then we make use of switch, right? And if the traffic is very high, then we make use of switch as compared to hub. We can also use hub, but it is for small network. Then there is a bridge, which basically divide the collision domain, right? It helps to improve the efficiency of the network in some context. We will discuss that thing, how it will do in the future slide when this particular topic will come for discussion. Then there are some there is a need of firewalls in order to protect them from some kind of miscellaneous attacks. So we need a firewall for that, right? And already I told you that the role of router is to get interact or to get connected with the different network, right? So that's the difference between a router and a switch, basically. So switch is basically used for a LAN, local area network, which is working in a layer 2, right? uh, like data link layer, right? Whereas your router is working in your network layer, that is layer 3, right? Whereas a repeater, which is basically to regenerate the signals. So all these are the some kind of internetworking devices, and they have some significance, and for that purpose we are using them, right? We will discuss this thing when this particular topic will come in our chapters, right? Then according to our syllabus, what we have in the first unit is about OSI layers. We are going to talk about some introduction about the internet protocol version 6, right? Some kind of detection techniques. So all these things will be discussed in unit 1, where I can just show you, if you go back to the syllabus, where we can see that representation of data and its flow network, right? Different type of topology, right? Where we having star topology, ring topology, where we having bus topology. So what is the significance of all this topology, and which topology we are currently using in our labs, right? Please remember this thing. This type of question may ask you in an interview, that in this lab which type of topology we are using, right? So if please remember, if we are using a switch or we are using a hub, then you can say directly it is a star topology, right? If there is a device which is switch or hub in a network, and computers are connected with that switch and hub, then directly you can say that this is a star topology, right? All that thing we will discuss. Then what is protocols? uh, like we have discussed yesterday, that we have two versions of protocol, uh, and internet protocol is also there, IPv4, IPv6, right? And other protocols are such as we are using hypertext transfer protocols for application layer, right? And or FTP protocols. All these things are there, come in this category. And standards, where this is the OSI model, which we are saying that 7 layers. We having a transmission medium, which we have two types, that is wired and wireless medium. There we have that's why it is called LAN, and other one is wired LAN, other one is wireless LAN. So LAN is a local area network. That labs that we have in our college also, that is a local area network, right? That local area network can further be characterized into two parts. One is known as wired LAN, other one is known as wireless LAN, right? So wireless LAN means we are making use of Wi-Fi, right? All those connections that come in picture. So this is what we will going to discuss, the physical configuration of a networking, basically. There are virtual LAN also, we are going to talk about how we can create virtual LAN, techniques of bandwidth, right? So the actual data transmission that take place between the sender and receiver, and the uh, signals we are getting, right, it depends upon that, right? So this thing basically varies according to the network we are going to use. Either we are going to use wired or wireless. So efficiency may goes down when we are talking about wireless, right? So we will definitely going to discuss the difference between the efficiency of wired and wireless network. Then there is a need of multiplexing, and due to the fact, since we are having lots of users and we are having a single channel, right? So how we can make use of that single channel in an efficient manner. So that will be the main objective of this topic when we're going to discuss that, without any contention, right, without any contention or mixing of data, how we can transmit our data from one place to another place. That will be the objective of this particular topic that we're going to discuss. In this, we having different class. We having frequency division multiplexing, we having a time division multiplexing, wave division. This is belongs to the light. We are use it in fiber optics. We, since we know that light have that different wavelengths, that red light, green light, all that. So we will discuss that thing. And then finally the spectrum, right? So we having a range of spectrum for the frequency, right? Suppose if we talk about Wi-Fi, we have 802.11, right? Then for Bluetooth, we having 802.15, right? Like this way. For Zigbee, 802.15.4. So all these are IEEE standards, or the technical name which is given by the organization to this technology, right? This will be the your first module that we're going to discuss. In second module, we are talking about the data link layer, right? So the layers will come in picture one by one. So that's what I am saying. Moving back to the slide, that is all about unit one that we will discuss, right? And then we will talk about the data link layer, where we in our second unit, which says about over here you can see that data link layer has some functionality. There are some specific roles, and those roles are uh, defined as framing, right? First of all, since we are segregating them in some frames, all that bits, zeros and ones, they will get segregated so that we can able to know where the data is started and where it is getting over, and when the next frame gets started. So we need some kind of limiter, we need some kind of delimiters, which will basically distinguish, and which will basically tell the receiver that okay, this data is completed over here, now the next frame is coming, right? So for that reason, we are make use of these concepts, and that will be done by data link layer. And that's why it's talking about frames, right? So framing is done over here. Other roles and responsibility of data link layer is which is not mentioned over here, is error detection and correction, right? So it might happen in between when we are transmitting in our open network. As we know, internet is an open network where anyone can use and access uh, the channel they are transmitting. So because of attenuation, because of some kind of noise in a channel, or because of some kind of attack, there could be a possibility that your data might has been tempered or changed because of these reason which I just told you. And due to that, what will happen, that zero has been turned to one, or one couple of ones has been turned to zeros. This could might happen, right? So if the receiver will receive this data, then how will can able to know that the receiver is received the uh, same data which sender has sent? Yes. So for that reason, we need some kind of error detection Okay, this error detection means that please remember this point which I am just telling you. Detection is always in receiving end, right? So once the data is received by the receiver, so detection, who will done the error detection? Receiver will do the error detection. And what he will do, he will identify, he will perform some kind of mathematical calculation based on the checksum, right? So along with data, we are also sending some other parameters such as checksum. All those fields will be there when particularly we will talk about internet protocol version 4, right? In that we will see that how data is placed, what do you mean by checksum, what is time to leave, what are the protocols, what is framing, right? All these things are there. They are flags are there, right? So there will be a source address, there will be a destination address. All these things will be the part of IPv4. So a receiver, when receive a packet, it has the checksum of that packet, and with that checksum it is going to match that the data which it is received is correct or not. So that's why I'm saying that when the frame is received is at the receiving side, receiver has this responsibility to detect the error, right? So data link layer has this responsibility which says that error detection, and if possible it can also correct it. That data could be again back to the original, but that depend upon the type of technique we are using. For example, we have one technique which is known as Hamming code, right? So but this technique is having some limitation. It cannot uh, able to recover the data if we have lots of bits is corrupted, right? It can only perform for some few number of bits, right? If more bits are corrupted, then it cannot able to correct them. So that is the challenge with this particular technique. Other techniques are also there that is basically used for correction methods, right? Correction will be done only after detection. Please remember this thing. Once detection is done that yes, the data which is received is not equivalent to the original data which is sent by the sender, then what will be done? There will be a correction mechanism, right? So you can see over here that is data link layer, and over here the devices which are working are, you can see bridge is a device which is working over there, switch is there which is working, right? Since it is talking about MAC layer, so there is a Ethernet, as I told you. This is a special type of address which is given to your Ethernet card, right? So in our PC, as I told you, we have Ethernet card, just like RJ45, right? That Ethernet card is basically uh, talking about that how we are going to connect, right, from one node to another node. So you can see uh, that switch is basically used to connect with that, and in switch we have all those Ethernet card over there, right? And one of the port in a switch is used to connect with one of the node that we want to connect, right? Similarly, more nodes could be connected, right? And so on, right? So what we are saying over here is that this switch is basically working in which layer? That is in data link layer, right? We will discuss this thing in detail when the chapter will come, unit 2. Over there, when we will discuss this role and responsibility of data link layer, how framing is done. And one more thing that I want to tell you about this layer is that over here the communication is between node to node. That is the node which is immediately connected, right? Directly connected to the node. So one node is going to connect with another node, right? So data link layer is responsible, having the responsibility between one node to another node. In a sense, it can maintain some kind of synchronization between each other, right? These are also some of the advantage of data link layer that we'll discuss. So delivery of data uh, will be done on this node to node, right? Node, whereas over here you can see in network layer, here the responsibility is from and node till end node, right? From the host, which is a sender, to the host, which is a receiver, right? So here we are making use of internet protocol, right? Yesterday we have seen ICMP, that is internet control message protocol, right? Which is basically used as a ping command to identify that network is connected successfully or not, or some error is there. We can connect to that network or not. We can able to reach to that node or not, right? Then we are saying that for security we are having this protocol, since by default IPv4 or that IPv4 internet protocol does not have any security mechanism in it, right? So we have an external protocol, that is internet protocol security, IPsec, which is used for providing confidentiality and integrity for our data packet, for our packets, right? Now you can please see over here that in network layer, the frame which is equipped with IP address, you can see over here in a frame, when we equipped it with IP address, it become a packet, right? So here we having a packet, we named it. So when we are talking about packets, remember it is about network layer. When we are talking about frames, remember it is about data link layer, right? Then moving to the last one, that is the physical layer, where we can see we are talking about the topology, we are talking about the physical structure of the network, right? The wired, the coaxial cables, right? The cat cable, we having different cat cable 4, 5, 6, which is basically used for transmitting data, and it will deal with some kind of its speed, at which speed we are transmitting data, like in which we having 100 mbps of speed for wired, right? That 100 mbps of bits that could be able to send from one place to another, when if we are using that cat 5 cable, we using your ethernet port, right? That is RJ45. It has two mode, one is 10 mbps per second and other one is 100 mbps per second. Whenever you have a hardware in your hand, you can just check it out. You can see over there it is written uh, by the company that 100 slash 10 mbps. Definitely I will show you in the slides, in the future slide when it will come to you. Other things are like, these are the cable, coaxial cables, these are the fiber cables. Other medium that we have in through which we can able to make use of the concepts of networking are wireless mediums, right? So in wireless we have Wi-Fi, we have Zigbee, we have Bluetooth. All these are the wireless technology that could be used for transmitting of data, right? But yes, definitely they have some differences. They have differences depending upon the range, distance they could able to travel. Like for example, in Wi-Fi we can able to transmit our data up to a limit of 100 to 200 meters, right? Similarly, when we are talking about Bluetooth, it has a range of transmitting of data between 10 to 20 meters, right? But definitely there will be some positive aspects also. There are some negative aspects also. If we talk about Wi-Fi, it basically consume more power with respect to Bluetooth, definitely, where Bluetooth is a low power device, and it can retain for longer period of time. It could easily able to work on batteries, where Wi-Fi is not feasible to work on batteries, because it basically facilitate high bandwidth, right? It basically facilitates us long range of data communication, right? So depending upon the requirement of a network, we basically opt for these technologies at the point which I want to tell you, right? So all you can see hub and repeaters, they come under physical layers, right? As I told you, they don't hub is a used to connect a small network, and it is just like an extension where we want to connect more than 2 or 3 computers together, then we can go with this hub. But you have already seen that the working principle of hub, which says that the packet will get copied, and then it will be broadcast to all the ports through which it is connected, except from where the packet has arrived, right? So in that manner the hub is working, where the need of hub still is that it is low cost. It is of low cost. Please remember this thing. Why it is still existing in market? Because of its low cost, and where we don't have heavy traffic, we don't have many computers, then we make definitely make use of this hub, right? Whereas in this switch you can see that there are more number of nodes which we want to connect in a LAN, and there is a heavy traffic, then we make use of this switch over there, right? So this is all about the unit 2, which says that how the data is being transmitted in our medium, that is our wired medium or wireless medium, right? So for you can see one more category is there, that is optical fiber, where we are making use of light, that is uh, it will travel, and it has since it is made up of all that 7 lights, you can 7 colors, and they have different wavelength, so we can easily transmit them, and from one place to another place using the concept of fiber optics, right? So for that we need some kind of converter first of all, because here we having a analog source, right? And we need to convert them into zeros and ones, because our system, our computer, it only understood the values zeros and ones. Once we received the digital form of data, uh, what we can do, we can easily convert it into light pulse. We can easily convert into light pulse. When if it is on, we will send the light. If it is off, we will not transmit the light, right? In this manner we can distinguish the digits zeros and ones, and we can make use of pulse light, which could be easily travel, and you can see it could travel with the speed of light, which is very high. So we will get a very you can see high bandwidth in case of this fiber optics. Please remember this thing, right? So fiber optics having very high bandwidth because of this reason, and because of very less resistance over here as compared to the copper cable, right? The coaxial cable, or we are using the cat cables for connecting the devices. Over there also we need a converter, right? And we need to send uh, for if we are transmitting the digital data, we want to transmit a digital data, then we need a converter. Otherwise we need, so all these concepts are come under modulations. These are known as modulations techniques, right? We will discuss that thing, what is a modulation, right? So unit 3, the next what we have is unit 3, which says about data link layer, and in which we are having sorry, unit 3 is your network layer, which talks about, just hold on, going back to the syllabus. Yes, unit 3. So unit 3 is talking about network layer, right? Few more things that I want to tell you before going to unit 3. That is, we are talking about when we are talking about a data link layer, there is one more thing, that is flow control, right? So it is very important to understand that the data you are transmitting to the node. Now look at this picture. You can see over here, this is one network device, this is another network device. So link layer is also responsible for the flow control of data between these two devices. That's why it is called node to node delivery of data, because it is connected immediately to this node, and it is acting as a source for this router. So if there is no flow control between these two devices, whatever the data we are exchanging will not be received in a proper manner. There could be a case where some of the data will get lost in a network, since memory is full, or since receiver is not uh, in a situation or in a condition to receive more data at that time. There could be a case of congestion, right? So to maintain that type of thing between these two nodes, like, or any other node like these two nodes or these two, and that's why I'm saying in data link layer we are talking about node to node delivery of frames, right? So it is saying over here we need some kind of flow control mechanism, right? So that's why it is written over here there is a flow control, and for that we have then classified them with some protocol. So some one of the basic protocol is simplex protocol. How this thing gets started when there is no control, so that is a simplex protocol. Then we one step by step we have inserted some methods, and we come to know that if we continuously keep sending the data, then and we are not getting the acknowledgement, then how the sender will know that data is successfully delivered? That is a problem, right? So in that case, then uh, a new protocol come in picture. That's why it is known as stop and wait protocol. We say that we will first send the data, then we will wait. What we will wait for? We will wait for acknowledgement, right? Then but over here one packet is sent and we are getting one uh, acknowledgement, right? So till then what we have to do, we have to wait. So it is not going to provide you that much you can see uh, bandwidth, or it is not going to provide you uh, that much network flow of packets, right? So or basically you can say it is inefficient, right? So to improve the efficiency, then we improvise this protocol, and that's why we have go back n. Now that n, basically we can able to send 10 frames, 20 frames in one go, and then we are going to wait for the acknowledgement. As we are going to receive the acknowledgement, we are going to slide this window. So that's why these come under sliding window protocols. Go back and selective repeat, these are the sliding window protocol, right? So in this manner we will going to talk about data link layer, and this is very important layer, as lots of the questions may come to you for your gate exam also from there, right? So please pay attention when we are covering this chapter, right? Then there is a, as I told you, you can see in the picture that data link layer is further divided into these two. That is logical link control, and other one is the MAC sublayer, right? So the other portion of this syllabus, that's why it is talking about now the MAC protocols, right? So which are Aloha, right? Which basically says that how multiple user can access single device simultaneously. Now just imagine if multiple device will access the channel or access the device at the same time, then what will happen? There will be a collision. So to remove that problem, to remove this problem, that is the collision, the contention between the nodes which they are willing to access the channel first, right? And all of them are trying to access the device or that channel, then what will happen? There will be a collision. So we need a mechanism which will balance this thing, right? For that we have this MAC protocol, and in the from it started with Aloha, since it was created over there, and we have other version of Aloha, that is slotted Aloha. So we just give a time complexity over here, which basically increase the efficiency. So over here you can see Aloha have only 16% of successful delivery of packet, whereas just by introducing slotted Aloha means we have divided the uh, into some slots, time slots, right? and we put some conditions over there, and with that changes only, what we have identified that it has improved to 30 to 36%, right? So efficiency is doubled just by introducing this concept of dividing the slot with with respect to some time, and